So, good afternoon, everyone, and welcome to this lecture. This is lecture number 5 in SHM, and we are dealing, I think, in the last lecture, we had dealt with energy, potential energy, kinetic energy, and total energy. I am expecting questions on this, and that is why we are emphasizing so much on this part. We had started some question on energy. We had seen their graphs. We had seen everything that was around. The theory part is over. I hope you remember these graphs. This is the graph of total energy, kinetic energy, and potential energy plotted as a function of time. And on the above, it is plotted as a function of x. Remember, total energy remains constant in a simple harmonic motion, and that is one of the most important things about a simple harmonic motion. We understand this, yes or no?
Yes, sir.
Okay, so I'll give you one small example, and you need to tell me the answer for this one. Remember, these are the pet type of questions that have come many times. So let us start with this one, and I hope you can give me the answer for this motion. Question number 1 for today. In case of simple harmonic motion, what fraction of total energy is kinetic and what fraction is potential when the displacement is 1/2 of the amplitude? That is first question. The second one is, at what displacement the kinetic and potential energies are equal? So, you understand the question, yes or no?
Yes, sir.
So tell me the answer. For this one, I'll give you 2 minutes.
Okay.
In A case, it is 1/4 and 3/4. Kinetic energy is 1/4. Potential energy is 3/4. Is that so?
Potential energy is 1/4, sir.
Okay. So you just have to put the final formula of kinetic energy. Kinetic energy is half m what? Half m v square, right? And v is omega square into a square minus x square. Yes or no?
Yes, sir.
And potential energy is half m omega square or k square, whatever you want to write, into x square. Yes or no?
Sir.
So when the displacement is half, so you just need to put the value of x. And what is the value of x you need to put? The value of x you need to put is x will be equal to a by 2. Yes or no?
Yes, sir.
So from there you can get the value of kinetic energy and potential energy. What is the value of kinetic energy that you are getting?
Kinetic energy is 3/4, sir.
Half m omega square into a square into 3/4. Yes or no? Yes or no?
Yes, sir.
And the potential energy you will be getting as half m omega square into a square into 1/4. Am I correct?
Yes.
So from there you can find out the ratio. Yes or no?
Yes, sir.
The ratio of kinetic energy to potential energy, K by U, in this case will be 3/1. Yes or no?
Yes, sir.
Okay. At what displacement the kinetic and potential energies are equal? So you
A
basically
by root 2, sir.
so x will no, not a by root 2, plus or minus a by root 2. There are
Okay.
two values, this side as well as that side. Do we understand this, or this has gone above, or that's saying bye bye, bye bye, I'm going bye bye? Huh? You understand this?
Yes, sir.
Pakka na sir?
Yes, sir.
This one, quick question, give me a quick answer. Eh? Question number 2. What is the answer for this one? A particle of mass m is hanging vertically by an ideal spring. We have not come to that spring. But you must be knowing that whenever it is hanging by a spring of force constant k, what type of motion is there? It is made to oscillate freely. The total energy is, what is the correct option out of the 4 options that are given?
B, sir. Same.
Huh? Same at all, because the only two forces that are acting are gravity and spring. Both are conservative. Energy will be, mechanical energy will remain constant. Whether or not the motion is simple harmonic or not, that does not make any difference. You understand this?
Yes, sir.
Okay, then this question, sir, and the reason why we are doing this question is that you understand that you can get a question where potential energy is not zero at the mean position. So this is the question that you wanted to do. Question number 3, I told you potential energy may not be zero at the mean position. The potential energy of a particle oscillating on an axis is u. We did a similar question on force. I hope you remember that question. Do you remember that question on force, huh?
Yes, sir.
Where U is in joules and X is in meters. Total mechanical energy of the particle is 36 joules. State whether the motion of the particle is simple harmonic or not. Say, is it simple harmonic or not? That is the first question. Find the mean position. That is the second question. Find the maximum kinetic energy of the particle. That is the third question. Maximum kinetic energy of the particle. That is the third question. And they have not asked you what is the extreme position. You can also find out the extreme position once you know. Anyways, you have 2 minutes to deal with this one. And I hope you can come with the goods. I'll give you 2 minutes. Tell me the answers, what you have got. Yes.
Mean position is 2, sir.
The mean position is 2, sir. How did you get mean position as 2? It felt like that, sir.
Potential energy is minimum at Chappu.
Sir, at mean position, potential energy is minimum, sir.
Okay, and that is why you put X as 2. Okay, good.
Yes, sir.
Okay.
Kinetic energy is 16 joules, sir.
Kinetic energy is 16 joules.
That is maximum kinetic energy.
Great. Good. What is the value of K here?
1, sir.
How did you get the value of K as 1?
1 or
Find out the force constant. And if the mass of the particle is m, or say 2 kgs, the mass of the particle is 2 kgs, find out the omega for this. That would make the question interesting. You got the answer and you got it by the correct logic, so I cannot say anything about that. But yeah, good one. I was not expecting such a quick answer. That is good. But you have to find out the omega of this particle. I've given you the mass of the particle as this. You have to tell me the omega of this particle. The omega, I mean the angular frequency of this particle. Yes. How do you find out the angular frequency of this particle? Omega of this particle. Okay. Yes. And how do you find the amplitude of the particle? One more question.
sir,
Yes.
for amplitude, potential energy is maximum at mean extreme position.
right?
So U will be equals to 36 at extreme position. That is equals to total energy. So from there, we can get amplitude as 6.
6. 6. 6 is the amplitude. No, 6 is not the amplitude. Herbert. 6 is the amplitude. Okay, let us see. Now, you have applied the correct logic. U has been given as 20 plus x minus 2 the whole square at mean position. U is minimum. Now, since the value of U was given in this fashion, this particular fashion, you can easily find out that U minimum happens at x is equal to 2 because the question was given in such a fashion. So you got saved by that. So the mean position happens at x is equal to 2. But you did not answer the very important question whether the motion is simple harmonic or not.
It's simple harmonic, sir.
Okay. Okay. I assume that you know that it is simple harmonic. That's just an assumption. Find out the mean position. I found out the mean position. Find out the maximum kinetic energy is the next question. So you can find out the maximum kinetic energy. How do you find out the maximum kinetic energy? So how do you find out the maximum kinetic? Total energy should remain constant.
Yes,
Total
sir.
energy should be equal to kinetic energy plus potential energy. Now kinetic energy is maximum at the mean position. So I just use this equation at the mean position. At the mean position, this is 36. Should be
Yes.
equal to K max plus at the mean position, the potential energy is 20. So kinetic energy maximum is 16 joules. Well done. But it did not answer the very important question. How do you find out whether the motion is simple harmonic or not? Now remember, if this question was given in some other fashion, it may not have been so easy to find out the minimum value of potential energy. Since the question was given in this form, it becomes easy. To find out the mean position or the minimum value of U, what should you do to find out the minimum value of any function? What you have to do to find out the minimum value of any function?
Sir,
How do you find out the minimum value of any function?
minimum value of the
Minimum value of anything, any function. How do you find it out?
sir, we take the differentiation of
Yes. So that is what you have to see for U minimum. And if the du by dx has to be equal to what?
0.
So you differentiate this. What is du by dx? Du by dx will be 2 times x minus 2. Yes or no?
Yes, sir.
That has to be 0. That implies your x has to be equal to 2, and that is your mean position.
Yes, sir.
Now, instead of thinking in this way, you could have thought it out in a different way because you know that this is an energy function and this energy function must be related to a conservative force. And for the mean position, equilibrium position, the force acting on the particle has to be 0. Yes or no?
Yes, sir.
And force is nothing but.
Minus du by dx.
So you find out du by dx or you find out minus du by dx is the same thing. You are trying to find out the force. Yes or no?
Yes, sir.
So you could have said this in this way: force, which is minus du by dx, has to be equal to 0. So basically minus du by dx becomes minus 2 times x minus 2. Do we understand this?
Yes, sir.
Or it has gone above that saying bye bye?
Understood, sir.
And that should be equal to minus k into x. Now I'm writing this x in place of x minus 2 because this x is actually x minus 2, and it is giving us a displacement from the mean position. The mean position is at x is equal to 2. Do we understand this?
Yes, sir.
From there you can find out the value of k.
Okay.
The
It is
value of k is 2. Do we understand this, or this is gone above or saying bye bye?
understood, sir.
The value of k is 2. Now you can find out omega for this one as well. Omega is equal to under root of k by m.
Omega
K is
is
2.
equals to 1.
So it will be 1. Do we understand this, or this is gone above our head saying bye bye? Bye bye.
Understood, sir.
So we could have found out everything in this way also. We could get the value of k, we could get the value of anything that we aspire for. And this is the important problem that makes you understand that potential energy may not be zero. Potential energy could have been given as a different function, not at x minus 2. Then it becomes difficult for you to find out the minimum value. For example, I could have given u as x square plus 2x plus 3. Then how would you find out the mean position? Same thing, du by dx is 0. That is the mean position. Do we understand this, or this has gone above our head saying bye bye?
Understood, sir.
So remember the simple things and remember this. So this is how you find out if a equation is given, energy is given. This is how you find out. This is how you find out the all of the other values. Yes or no?
Yes, sir.
Okay, now in some cases you might be asked to find out the omega for SHM, to find out the angular frequency. Those are the first type of question that you encounter. Now, if in any question, in any general question, you are supposed to find out the frequency and time period of SHM, if the equation is not given, if the equation is given, you can just compare the equation and get. There might be cases where you are given a diagram, find the SHM, find the omega for this SHM, find omega for this SHM. In JEE main that question may not come, but what is the general method of finding? General method of finding, general method of finding omega and t. Then there are two methods, and there are two methods to find out the omega or time period. One method is known as the force method. The other method is known as the energy method. Now, what happens in the force method? So, the first method is known as the force method, and this is more likely what we are going to do, and I'm only going to tell you this force method. Now, what happens in this force method? And you will quickly write it down, and then I will just solve one problem based on this, and then I will leave everything else. So what happens in force method? You do it step by step. What is the first step that you take in a force method? You have to first understand. You have to first understand. You have to first look at you can read this, or shall I increase the size? You can read this. Okay, just make it bigger. So step number one is what? You look at the diagram and you find out the equilibrium position of the particle. Now in this equilibrium position of the particle, you will have to draw the free body diagram, and you need to balance out the forces. The body is in equilibrium, so the net force has to be 0. There might be forces acting on the body, so you will get the first equation from step number one. Step number one is to draw the free body diagram of the body in the equilibrium position and draw the forces and find the condition of equilibrium. Do we understand this? Yes or no?
Yes, sir.
Okay, then comes the next step. Please first listen to what I'm saying, and then I'll give you time to write it down. Don't worry. First listen to what I'm saying. So what is the next step? Once you have drawn the equilibrium condition, then what will you do? From the equilibrium position, displace the particle via very small displacement y. By a very small displacement y, you have to displace the particle. Since you have displaced the particle, it will not be in equilibrium. You have to find out the net force on the body. What is the net force acting on the body? Do we understand this? So basically, you have to find out when you displace the body from this equilibrium position, you have to find out the net force acting on the body. Do we understand this?
Yes, sir.
You have to find out the net force acting on the body. What is the force? Then this net force, as I told you, is known as the restoring force. Why it is known as the restoring force? Because this will be trying to bring the body back to its equilibrium position. Yes or no?
Yes, sir.
So we have to find out the net force acting on the body. What is the net force acting on the body? Do we understand this?
Yes, sir.
Then we move on to the third step. And once we move down to the third step, I will give you time to write it down. Then once you find out the net force acting on the body, you will have to somehow relate it to the displacement, and you have to prove that this net force will be equal to minus of k into y. What do you mean by minus of k into y? It means that you will have to prove that this net force is directly proportional to the displacement. Do we understand what I'm saying? If you cannot prove that this force is directly proportional to displacement, the motion cannot remain simple harmonic. We understand this?
Yes, sir.
This negative sign only indicates that this force is opposite to displacement. If the displacement has to be towards right, the force has to be towards left. If the displacement is upwards, force has to be downwards. If the displacement is downwards, force has to be upwards. Yes or no? Do we understand this?
Yes, sir.
And then you can equate this force to m into a, mass into acceleration. So you can write your acceleration as minus k by m multiplied by the displacement y. That is step number 3. As soon as you get your acceleration as a function of time, acceleration as a function of x, this entire thing that comes becomes your omega square. So your k by m becomes your omega square. Once you get your omega square, you have solved the problem. Do we understand this, or this has gone above our heads, saying bye bye, I'm going?
We
Have you
un-
noted down step number 1?
Yes, sir.
Step number 2?
Yes, sir.
Then the last step is you just find out, compare this equation with acceleration, find out the value of omega, and just write omega, in terms of k by m, and that will be solving your problem once and forever. Do we understand this? Do we understand the step by step procedure of finding out the what? The omega for any given system that you see in a diagram. Everyone has noted this down? Yes or no? No, yes.
No, sir.
No, sir. Then I'll give you 2 minutes, sir. Let me know once you're done. Now, the simplest case of SHM would be a block which is attached to a spring. Yes or no? No, yes. Huh? That is the simplest case of a SHM. So that is the heading that we are going to write. Spring block system. That is the simplest form of SHM. That is the spring block system. Everyone knows this, yes or no? Huh?
Yes, sir.
Okay. So This is a simple helical spring. HELI. This is a simple helical spring. Everyone knows this. Yes or no about a spring? And whenever a spring is attached to a block and we extend the spring or we compress the spring, a spring force acts on the block. We have studied this, yes or no? We have studied this, yes or no?
Yes, sir.
Force acting on the spring is minus kx, where k is known as the spring constant of the spring. Yes or no?
Yes.
Pakka na? Okay. Now, whenever we are talking about spring, spring is considered to be massless. There is no mass of the spring. There is no mass of the spring. So, the force in the spring is assumed to be constant everywhere. If the mass of the spring is there, then the force becomes different and therefore things become slightly different. Everyone knows this. Everyone knows these things about springs, yes or no?
Yes, sir.
Then one thing that you must always remember, that the spring constant of the spring is inversely proportional to the length of the spring. What do you mean by length of the spring? If I cut, and this is the graph, if I cut a spring into two parts, K into L is constant. That is what you have to remember. K into L is a constant for a given spring. For example, if I cut a spring into two halves, the length of each half becomes half of the original length. What will be the effect on spring constant of that spring? Two springs that I create. The spring constant of those two springs will become 2 times. Do we understand this?
Yes.
Yes or no?
Yes, sir.
If I cut a spring into 3 equal halves, the spring constant of any half will become thrice. Do we understand this? So K into L for a spring is always constant. Everyone understands this.
Yes, sir.
Whenever the spring is compressed or stretched, energy work is done to compress it or stretch it. That energy is stored in the form of spring potential energy, and we know that spring potential energy is half kx square. Yes or no? Anyone knows this?
Yes, sir.
We have already done this. So it is exactly the same as what we were studying in simple harmonic motion. Yes or no?
Yes, sir.
This spring potential energy is exactly same as the potential energy in a simple harmonic motion. This is the graph of spring potential energy. This graph is exactly same as the graph of potential energy of particle executing SHM if the initial position is energy is taken as 0. Yes or no? Ah.
Yes, sir.
Then let us take the example of this SHM. Example number 1. Now, in this condition, when it is at its natural length, that will be the mean position. Yes or no? If the block is placed like this, nothing will happen. But if I displace the block by a very small amount like this, what will happen? The spring will try to bring it back. Yes or no?
Yes, sir.
There will be a force acting on the block. That force will be equal to minus kx, minus sign indicating that the force is backwards. And the particle will start to execute SHM. Yes or no?
Yes, sir.
And it is very easy to see that the omega for this SHM, it is exactly same as what we did. So omega square of this SHM will be equal to k by m. Yes or no? Because the spring force is k into x simply. So the time period of this SHM will be 2 pi root over k by m, root over m by k. Yes or no?
Yes, sir.
So if a block is kept like this, if the block is kept like this, it will execute SHM, and the omega for this SHM, we don't need to prove it. We understand that the omega for this SHM will remain like this. Yes or no?
Yes, sir.
Now if I have second case, now instead of the spring block system on a horizontal surface, if I hang it vertically, then what is the difference between case number 1 and case number 2? What is the difference between case number 1 and case number 2? Because of hanging, what has changed? If I hang a particle like this and then I stretch it, it will perform SHM. What is the difference between this SHM and that SHM? Case number 2 and case number 1.
Spring wind will be elongated, sir.
The mean position is not at the natural length of the spring. The mean position will be somewhere when the spring is extended. This is the mean position. Here the mean position was happening at the natural length of the spring. Here the mean position will not be at the natural length of the spring. Then where will that be where will that mean position be? What will be the value of x naught, which is the value of mean position? At what position you will have the mean position? What will be the extension in the spring in case of this case where the block is in equilibrium? When the block is in equilibrium, we call it the mean position. What will be the value of x naught for mean position? Where will the mean position be? It will not be in the natural length of the spring. Where will that be? Yes, tell me. Yes, where will be the mean position? Taking so much of time. Okay, you can write it here. The mean position here in this case is the natural length of the spring. Where will the mean position be? At the mean position, the force downwards is mg, the force upwards is F naught. Then this F naught is nothing but equal to K into X naught. This force must be equal to this force. So from there I can find out the mean position mg by K naught. That will be the extension in the spring. That will be the extension in the spring in the mean position. Do we understand this, or this has gone above what I'm saying? Bye bye. Bye bye. Do we understand this?
Yes, sir.
What will be the time period of simple pendulum? This is known as spring pendulum. This is known as spring pendulum. What will be the omega for this? Remember, the value of omega does not depend on whether it is hanging or lying. Omega will still be equal to root over k by m. Time period of this pendulum will be again equal to 2 pi root over m by k. The only thing that has changed is the mean position. Do we understand this?
Yes, sir.
Why it has changed? Because there was a force which was trying to pull it. Do we understand this? Or it has gone above our head saying bye bye sir, बहुत हो गया. Enough we had. Enough? Huh? Are we able to understand this or this is going above our heads? Please let me know if it is going above your head so I will do something else. This is case number 3. It is kept on an inclined plane like this. It is kept on an inclined plane like this. Again, you have to understand where will the mean position be? Will it be at the natural length of the spring or somewhere else? And what will be the value of omega b? What is the value of omega? And where will be the mean position of this? Yes. Can anyone tell me where will the mean position be? Will it be at the natural length of the spring? Or will it be extended or compressed in its mean position?
No, sir.
Will it be extended or compressed?
Extended, sir.
Thank God. It would be extended. Let us say the extension is 0. This is the mean position. Can you tell me what is the value of x naught? And it should not require rocket science.
mg sin theta by k.
What exists? What exists? mg sin theta by k will be the mean position. What about omega square for this?
K by
It
m.
will be same as k by m. What about the time period? 2 pi root over m by k. Do we understand it or this is going above our head saying bye bye? Bye bye sir, I'm going. Huh?
We understood.
Doesn't look like, but still I will take your words. One more case. Remember, these are not cases, these are potential questions that are going to come in your exam, my dear friends. I hope you understand the importance of what we are doing here, right?
Yes, sir.
Yes, sir. No, sir. Better I go, sir. Better you go, sir. I made one more fantastic case for you, straight from the fridge. Chilling case. Now I have a block kept like this. Now remember, this case could have been done in various ways, but what I have done is I've applied a constant force F on this block. I've applied a constant force F on this block. This F is a constant force I've applied on this block. The question is, will this block execute SHM? If yes, then you have to tell me the time period, and you also need to tell me the value of x naught, which is the in its mean position. Will it be extended? Will it be compressed? Or will it be in the natural state?
It will be extended, sir.
It will be extended, sir. Well done, sir. So now tell me what is the extension in the spring for this mean position. Where will the mean position be? Where will the mean position be? Huh? We don't know, sir. Yes, sir, or no, sir?
X not equal to F by K.
X naught equal to F by K. That is correct, my dear friends. Omega square is still K by M. That does not change. Time period is still 2 pi root over M by K. That does not change. Do we understand this, or this is gone above our saying bye bye? Bye bye. Bye bye, sir. Bye bye. Huh?
Understood.
All these are questions. We are doing questions. We are not doing cases. Now I have spring or spring constant K. This has a mass M and a charge Q. And this is placed in an electric field. I know that you don't know what is electric field. But I hope that you must be knowing this much at least. Now I place it in a uniform electric field E. Electric field E is uniform. Will the particle execute? Will the particle execute SHM? If yes, what will be the time period? What will be the value of X naught in the mean position? Where will that mean position be? Can you tell me that? Yes or no? No, yes. No, sir, we don't know, sir. What, sir? Huh, sir? You know it, sir? Will it be extended or compressed in its
Sir,
mean position? I mean, yes, in the mean position, will it be extended or compressed? Yes.
sir, it is positive charge or negative charge?
Positive charge. I always think positive. I never think negative in my life. So it is a positive charge.
Sir, the spring will be extended. Sir.
Thank God. See, God exists. L naught will be the max. Will be the natural length. X naught. What is the value of X naught? Huh? Sir, we don't know, sir. X naught will be equal to QE by M. QE is the force divided by mass M. Omega square will still remain K by M.
Sir,
Time period.
2E by M or K, sir?
Oh, sorry, 2E by K. Why I am writing M? 2E by K. Time period still remains 2 pi root over M by K. Do we understand it? Or this is going above our head saying bye bye, sir. बहुत हो गया, बंद कर दो. हाँ?
Understood, sir.
पक्का no, sir?
Yes, sir.
I get scared of your पक्का पक्का. So it doesn't matter if it is attached to a spring and you apply a constant force F. The only thing that is going to change is the mean position is going to go here and there, but the motion still remains simple harmonic in nature. Next case. What is the number of this case?
6, sir.
6, sir. Now in this case, what is going to happen? This is just for your thing. In this case, the spring has a mass ms, so you might get a case where the spring has a mass. So basically, if you get a case like this, spring has a mass, the only thing that has to change, the only thing that has to change is the mass. The effective mass becomes m plus ms by 3. So basically, because of the mass of the spring, the force is not constant in the spring, and that creates some mathematical things. And because of that mathematical things, my omega square becomes k upon mass of the body plus ms by 3. Ms by 3. Total not divided by 3. Ms, mass of the spring, divided by 3. Do we understand this? So the time period becomes 2 pi root over m plus ms by 3, the entire thing divided by k. Do we understand this? Yes or no? No, yes. Huh?
Understood, sir.
Understood, sir. Abhi, I'll get to know, sir, when I give you a question, sir. Then you will look here and there, sir. Okay. Now, many times you might see a diagram like this. And remember, all these are questions that we are doing. They are not cases, they are questions. Each and everything is a question. I hope you understand this. Huh? Now, remember, you can have two masses connected like this. We are coming to two mass system. But remember here, this mass, this M2 is fixed. M2 is not oscillating. The only, M2 is not going to go dhar, 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 upar, niche. The only thing that is going to go upper niche is this M1. So this is the only mass which is oscillating. Do we understand this? This is the only mass which is oscillating. And in this case, your omega will become, okay, if this is the case, first of all, where will the mean position be?
It will be compressed, sir, spring will.
God exist. Always try and what? Try and what? Understand that God does not exist, but then God exists. So basically, it would be compressed. If the L naught is like this, it would be compressed. By how much amount would it be compressed? This compressed. Do you understand? It is compressed here by x naught. How much is x naught? This is the mean position. Let us say. How much is x naught? I don't know, sir. The mass of the upper block is m1. Let us say.
Sir, it is x naught equals to mg by k, sir.
X naught will be equal to m1g by k, the oscillating mass. Omega square will be equal to k by m1, the oscillating mass. Time period is 2 pi root over m1 by k, the oscillating mass. I hope we understand this. Yes or no? No, yes.
Understood.
Understood, sir. Understood, sir. That is good, sir. If you understand it, sir. Nothing like it, sir. But sometimes you might have what? Two blocks attached to a spring, and both the blocks can oscillate dhar, 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 like this. Then what happens? Which case is this? I don't know, sir. Which case is this?
8, sir.
Case number 8. You may have a system like this, where two blocks are, both the blocks can oscillate. Both the blocks can oscillate. Now, to make them oscillate, we have to first compress or extend them. Let us say the initial compression. Initially, they are like this. So, first of all, To start the motion, you have to compress or extend them. Yes or no? Now remember, these two blocks will have the same omega, and that omega is given by m1 m2 upon m1 plus m2. Oops, what I'm writing, ulta sab kuch. This omega will be equal to k divided by mu. That is better way of writing. Mu. Have you heard this mu anywhere? This mu is known as the reduced mass of the system. And the value of this mu is m1 m2 upon m1 plus m2. So both the blocks will be oscillating with the same angular frequency k by mu. You cannot take the mass of block 1, you cannot take the mass of block 2, you have to take the combined mass. It's not combined mass, it's known as the reduced mass. m1 m2 upon m1 plus m2. Time period will become 2 pi root over mu by k. Instead of writing this entire thing, I can write it as mu. Do we understand this? They will have the same angular frequency, they will have the same time period, but their amplitudes will not be same. Their amplitudes will not be same. They will have different amplitudes. They will have different amplitudes. And what? M1 into A1 will be equal to M2 into A2. Do you understand the meaning of M1, A1, M2, A2? Huh?
Yes, sir.
What? M1 is the first mass. A1 is the amplitude of the first mass. M2 is the second mass. A2 is the amplitude of the second mass. Do we understand this? So that is the first equation that you must remember here. The second one that you must remember here is A1 plus A2 will be equal to the initial compression or initial extension x0. You have to initially extend or compress it by some amount to start SHM. Using this equation, you can solve and get the value of A1 and A2. I am going to give you the values. A1 will be equal to, inversely proportional, M2 into x0 divided by M1 plus M2. And your A2 will be equal to M1 into x0 divided by M1 plus M2. So their amplitudes are inversely proportional. Their amplitudes are inversely proportional to their masses. When both of the masses can oscillate. Remember, both of the masses are oscillating. Do we understand this? Yes or no? No or yes?
Understood, sir.
Pakka na, sir? Or
Yes,
all
sir.
these cases have gone above our heads, saying bye-bye.
Understood, sir.
Pakka na, sir?
Yes, sir.
Important points. All these are not important points. All these are questions that are going to come in the exam. Time period of a spring pendulum. Do you understand the meaning of spring pendulum? Mass attached to a spring is spring pendulum. Bob attached to a string is simple pendulum. Mass attached to a spring is spring pendulum. The time period of simple spring pendulum, not simple pendulum, is independent of acceleration due to gravity. Whatever you forget, you may forget your name. You may forget in a JEE exam, why are you sitting here? But you should not forget that time period of a spring pendulum, spring mass system is independent of acceleration due to gravity. Wherever you take, the time period remains same. You understand this?
Yes, sir.
What, sir? Yes, sir. What do you understand? That is independent of the what? That the
Acceleration due to gravity.
this is the lift. The spring pendulum is kept in this lift, and then I start to oscillate it. This lift is moving. This lift is at rest. This lift is at rest, not going anywhere. And I start the oscillation of this particle. What will be the omega for this one? It is kept in a lift. Lift. Yes. What will be the omega for this one? The omega for this one will be equal to omega square will be equal to K by M because the lift is at rest. Do we understand this? Do we understand this, or this has gone above our head saying bye bye? I think it has gone above our heads. Okay. Now this lift is moving upwards with an acceleration A. Ding, 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 ding. Now I start the oscillation of this spring pendulum. This lift is moving upwards, remember, with an acceleration A, remember. And if I start the oscillation, what will be omega for this?
Under root m by k, sir. Sir, omega square equals to under root omega square equals to k by m.
If it is moving down with an acceleration A, same. It does not depend on acceleration due to gravity. So it remains same. Anyone understand this, or this has gone above our head saying bye bye? Bye bye sir, हो गया, आज का काम हो गया. Note it down ना?
Yes, sir.
पक्का ना sir?
Yes, sir.
Then these simple facts. Time period of a pendulum is directly proportional to the mass and inversely proportional to the spring constant. So if you change the spring constant, then some things will happen. Clear na sir? Clear na sir?
Yes, sir.
Arey say na sir, I get confused na sir. You don't say, I get confused. If I get confused, I start doing stupid things. Pakka na?
Yes, sir.
Shall we move on to some questions? Eh?
Yes, sir.
This is the first question. A body of mass m is attached to a spring which is oscillating with a time period of 4 seconds. If the mass is increased by 4 kg, the time period increases by 2 seconds. Find the value of m. Any hope of getting an answer?
Sir, M is 4/3, sir.
Well done. So quick. My answer must be correct. 4/3. I'm getting it as 3.2. Is it same? 4/3 and 3.2? Definitely not same. Therefore, your answer is not correct, my dear friend. You understand, friend? Answer is not correct, my dear friend. So you must do better and better and better and better and better. Shall I do it for you?
1 minute.
It's a simple question, my dear friend. I don't know why you're not getting it. Anyone is chilling out, it seems. It's good to chill out.
Sir, it is 16/5, sir.
16/5, sir. The answer drastically changes, sir. 16/5 is 3.2, and that is the correct answer, my dear friends. Why it has taken so long? Huh? Why it has taken so long?
Sir, I have taken
I have taken time period as
increased by 2. No, sir, I have taken 2 seconds. 4/2 I have taken.
time period is t pi root over m by k. In first case, the time period is 4 seconds. So read the question carefully. So 4 will be equal to 2 pi root over m by k. Then it has increased by 2 seconds. So it becomes 6 seconds. 6 is equal to 2 pi root over mass has increased by 4 m plus 4 by k. You simply have to divide it. So 4 by 6 becomes equal to root over m by m plus 4. And after this, you should be able to get the answer. The answer that I have is 16/5. 16/5, no? Was it so difficult for you to do this? How many of you could do this? Only one. What about the rest? Are we understanding better what we are doing here? This is a simple question where you had to apply simple formula. Have I given you too many formulas to apply? Because it's a simple question. I don't see the reason why you should not be able to get the answer for this question? I simply don't see the reason. Please tell me, what is the reason that you could not get the answer for this one? Chalo, one more. I hope you can give me the answer for this one. I am quite disappointed with the performance in this question. Not expected. A spring of force constant K is cut into two pieces such that one piece is double the length of the other. What will be the force constant of the larger piece? What will be the force constant of the larger piece? Any chance of getting an answer in this case?
1 minute.
1 minute to I have, sir. But after that, I will get impatient, sir. I have 1 minute. I can spare 1 minute. Not more than one. I'm really getting impatient now. I don't see any answer coming.
Sir, it is 3K by 2, sir.
Which option, sir? Option B, sir. It has been broken into two pieces. And the ratio of L1 by L2, L1 is to L2 is equal to 1 is to 2. And L1 plus L2 is equal to L. So you can find out the value of L1. Yes or no?
Yes, sir.
And L2. L1 will be coming as L by 3. Yes or no?
Yes, sir.
And L2 will be coming as 2L by 3. Yes or no?
Yes, sir.
Then I told you about the spring. K into L is constant. Yes or no?
Yes, sir.
That's it. That is what you have to apply. For the original spring, spring constant is K and length is L. For the new spring, bigger part, the spring constant is K dash and length is 2L by 3. So from there you can get the value of K dash as 3 by 2K. Was it so difficult that you could not do?
No, sir.
How many of you could do this? Chalo. At the end of the day, there is light at the end of the tunnel. Good. Last question for today. And I'm expecting quick answers. And here it comes, my dear friends. Two bodies M and N of equal masses are suspended from two separate massless springs of force constant K1 and K2. If the two bodies oscillate vertically such that their maximum velocities are equal, what is the ratio of amplitude of M is to amplitude of N? Question number 4 or 5, whatever it is. Yes, my dear friends. Yes, my dear friends. Any hope? Shall I keep hope burning or shall I leave it? Yes, my dear friends. Bacho. Okay. I think we have not understood the question. The maximum velocities are equal. What is the maximum velocity in an SHM? A1 omega 1 A1 A into omega is equal to A2 into omega 2. Such a simple problem, beta. So amplitude A1 divided by amplitude A2 will be equal to omega 2 divided by omega 1. That will be equal to root over K2 by K1. Masses are same. So that is the answer that we are looking at. It's the simplest question that was given anyways. Go back home. Go through the entire thing, the different cases, and we will come back and solve many good problems in the next class, because in next class we will be trying to do as many problems, and by the next to next class we'll have to wind up SHM one way or the other. And we are almost there. We are almost there to the end of the chapter. Do we understand this? Yes or no?
Yes, sir.
See, the questions are very simple. Just go back home, look at all the cases. If you understand one, you will understand all of them. They are very simple ones. And I have given you all the information that you need. No one is going to ask you the amplitude. They are only going to ask you the angular frequency, and I hope you have understood this. So I will take a break and we dismiss the class. I'll see you tomorrow in the next class. Take care and God bless all of you. Bye bye.
Bye, sir. Have a good day, sir.
Same to you, beta. Please work hard. The results of hard work will always come. Don't worry. Take care.